Hello, lovely math peeps. Welcome to another class online. Today we're going to be working on geometric sequences. And so I just want to kind of remind you of a couple things. So a sequence, remember, is an ordered list of numbers. An arithmetic sequence is a specific type of sequence. It's a sequence where you're adding a constant number to go from one to the next. And today we're going to learn geometric sequences. So a geometric sequence, you will learn, you're actually going to multiply by a constant number to go from one number to the next. So if you have your own notes where you have printed the notes that I gave you, then go ahead and get those out. But here we go. All right, so like I was saying, a geometric sequence is going to follow the pattern of multiplying by a fixed amount to go from one term to the next. And the number that you multiply by to go from one term to the next is constant, meaning that that number will never change. Okay, so like a geometric sequence that you may see would be 2, 4, 8, 16, we could keep going, 32. And again, when you try to find the pattern of it, you're trying to find what am I doing to one term to get to the next term. And so if you kind of think about, all right, what am I doing to 2 to get 4? What am I doing to 4 to get 8? What am I doing to 8 to get 16? Well, if you multiply by 2, that'll actually do that for you. For instance, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, so on and so forth. So the pattern here is that you're multiplying by 2. So that would be a geometric sequence. Another sequence, because remember, it's not always going to be super duper easy in terms of finding the pattern. So I'm going to show you one where that could take you to the next level with finding the pattern. Would be something like this. And I know how we all love fractions, but just remember, they're just regular numbers too. We just have to figure them out. So like with this one, you're trying to think, okay, what am I doing to 1 to get 1/2? What am I doing to 1/2 to get 1/4? So on and so forth. And so if you kind of sit there and think about it, what number, like if it does end up being geometric, you're thinking, what number am I multiplying by to go from one to the next? And so what number could you multiply 1 by that would give you 1/2? Well, the only number that would work would be if you multiply by 1/2, because 1 times 1/2 is 1/2. Okay, and then you could test it, because to be geometric, you have to be able to multiply by that same number over and over and over to get the next term. So like if, for instance, I take 1/2 times 1/2, do I get 1/4? Well, when you multiply fractions, you multiply the tops times the tops and the bottoms times the bottoms. So like 1 times 1 is 1, 2 times 2 is 4, so that would work. 1/2 times 1/2 would give me 1/4. And then you could keep testing it. So if I take 1/4 times that, would I get 1/8? And yep, you would. And then if I take 1/8 times 1/2 again, I would end up with 1/16. So that makes that one geometric as well. And now, something else I want to show you with these is there's going to be some sequences that would be a little harder to figure out what that number is if it was geometric. So I'm going to show you one of those, and I'm going to show you a way to find what is that constant number that you would be multiplying by. So let's look at this sequence right here. So we got 0.2, 0.05, 0.0125, and then we have the last term that they give us is 0.003125. And we have to figure out what is the pattern. Okay, notice you could easily figure out if it's arithmetic, like what we did yesterday, by taking this one and subtracting the 0.2. So remember, you take one of the terms minus the one before it. And whatever number that you get there, if it was arithmetic, that's the number that you'd be adding each time. So if you do this, you'll figure out that it actually ends up not being arithmetic. So then, well, to check if it's geometric, we're going to look to see, are we multiplying by some constant number to get from one term to the next. Okay, so that actually, before we talk about this brings me to talk about what's called the common ratio. So the number that we end up multiplying by to go from one term to the next is called your common ratio. So for this one, the common ratio, which they label as with an R, common ratio is 2 because we were multiplying by 2 to go from one term to the next. With this one, the common ratio ended up being 1/2. Okay, so now what we're trying to figure out is what is the common ratio here if it ends up being geometric. Okay, so be careful, not every sequence is going to be arithmetic or geometric. There's all kinds of different sequences. These are just very specific. So what we're going to see is this geometric? Okay, so if it's a more challenging problem like this one right here, and you're trying to figure out what is that number that you're multiplying by, then to find the common ratio, you are going to actually take one of its terms in the sequence. You can pick any one you want, I just wouldn't pick the first one. You'll see why in a second. And then you actually have to divide by the term right before that one. And that's the reason why this is called the common ratio, because the word ratio is actually a fancy word for fraction. Okay, so you're setting up a fraction to find it. So if I was trying to find the common ratio here, I would just go to the side. I'd take one of its terms and then I would divide by the one right before it. So like for instance, I could take the 0.05 and then I would divide, well, the term right before that would be 0.2. So I would divide by 0.2. And so when I do that, I end up getting, and you can just type it in your calculator if you need to, 0.25. And so if this is geometric, then I would know that I am multiplying by 0.25 to get from one term to the next. So how do you check to see if it's geometric? Well, you keep multiplying by that number and see if you get the other numbers. And so if you, for instance, took 0.05 and multiplied by 0.25, you would check to see, do I end up getting the next term? And yes, we do. And then I would take it again times the 0.25 and see if I get this last term. And yes, I would end up with that one too. So that means it's geometric. And the common ratio, the number that we're multiplying by, is 0.25. Okay, so just to kind of practice this, we're going to do a couple problems down here. All right, so it says in these problems, find the common ratio and then find the next three terms. All right, so when we're looking at number 1, I'm going to go to the side and I'm going to see, okay, what number would I multiply by to go from one term to the next? And again, you could try to reason through it, kind of like what we did with these two first problems. But if that's not working for you, you can always do this right here, this little shortcut. Okay, so let's say that I'm just trying to think through it and I just, for some reason, can't figure out what am I multiplying by. Well, all I do is take one of its terms. So I could take like the negative 135. And then I'm going to divide by the term right before that. So the term that's right before that would be 27. And when I take those and I divide them out, I end up getting -5. So that means that if this is geometric, which since they're saying common ratio, that it probably is geometric then, I would be multiplying by -5 each time. Okay, so then to find the next three terms, you just keep that same pattern going. So I'm going to take the 675 and multiply by my -5. And so when I do that, I end up getting -3,375. And then I would take that one and multiply by -5 again. So when I do that, I end up getting 16,875. Okay, and notice I didn't put the comma in here because when writing out a sequence, sometimes it's confusing if you have a bunch of commas. And so typically I would not put commas. And then you have to do it one more time to get that last term. So when I multiply by -5 again, I end up getting -84,375. And then it would keep going if I kept multiplying by -5. So that is the next three terms of that sequence. So then the next one, notice it's got fractions again. We all love fractions. So I'm going to zoom in just a little bit. Whenever we do this one, this would be a harder one to see what is it that we're multiplying by. So this is why I gave you that little shortcut. Remember, you can always take one over the other. So with this one, I could take the 8/3 and then I would divide by, well, the term right before it is 4. And you could actually type this in your calculator, but if you do, you might want to put parentheses around the fraction. That way it'll calculate it correctly. And when you type this in, it's either going to give you the decimal, or remember, you could change it to a fraction. And so you should end up getting 2/3. All right, so then that means that you are technically multiplying by 2/3 to go from one term to the next. And you can actually kind of see that if you kind of reason through, like for instance, I looked at the 8/3, and then what do I do to that to get this to the 16/9? If you look at each number individually, you might be able to see what's going on. Like, what number do I multiply 8 by to get 16? Well, I'd have to multiply by 2. What number do I multiply 3 by to get 9? Well, I'd have to multiply it by 3. And so that's kind of a way to reason through it when it's fractions. All right, so to get the next 3 terms, we're going to continue that pattern. So I'm going to take the 64/81 and I'm going to multiply it by my 2/3. So 64 times 2 is 128. So that's what goes on the top. And then 81 times 3 is 243. So there's the next fraction, or the next term in my sequence. And then I do it again. Take this one times 2/3. So if I take the 128 times the 2, I get 256. And then if I take 243 times the 3, I get 729, excuse me. And then I do it again. 2 times 256 is 512. And then 729 times 3 is 2,187. And then again, because it could keep going, we'll put the little dot, dot, dot. All right. So that's just the basic concept of a geometric sequence. All right. So now we're going to talk about the different forms of these sequences, so that you could practice writing them in the different forms. So if you remember with what we talked about with arithmetic sequences, recursive form tells you what to do to go from one term to the next. So it has the a sub n in it, but then it'll also have maybe how it relates to either the term after it or the term before it. So remember, the term before this one would be a sub n minus 1. And then the term after that one would be represented by a sub n plus 1. Okay, remember, n is the position of the term. So this would be the term in the next position. This would be the term in the, I guess, position before that one. Okay, with the explicit formula, also called closed form, because it's based on the position of the term, remember, these will help you find terms that are a little later in your sequence. Because it's based on the position of it. All they have to say is find the, 60th term, and you'll be able to find it very easily with this formula, okay? And so this formula is actually used a whole lot when it comes to some of the harder problems, all right? So because a geometric sequence is different than an arithmetic one, it's going to have different formulas when it comes to the recursive and the explicit form, all right? So with recursive form, the geometric sequence would be written like this. You would have a sub n, so to find a term in your sequence. What you're doing to go from one term to the next, remember, is you are multiplying by the constant number. So to go from the term before that one, so the a sub n minus 1 term, you have to actually take that number and multiply by whatever your common ratio is. So that's the recursive form, is you are taking the previous term and multiplying by that constant number. And then remember, with recursive form, you always have to write down one of its terms in the sequence. So we usually write down the first term. Okay, so there's the recursive form. The explicit form of a geometric sequence remember, is based on the position of it. So you're going to see an n in this equation. All right, so the explicit form will help you find a term anywhere in your sequence very easily. So to find that, you would have to take the first term and you multiply it times the common ratio. And the common ratio is going to be to a power. It's going to be to the n minus 1 power. All right, so remember, order of operations, you have to do the exponents first. So a lot of times when you're solving these types of problems, you're going to want to do this part, like the common ratio to the exponent first before you can multiply by the first term. So this will come up in the next time that or I guess when we're solving problems with these. All right, so remember, a sub 1 is your first term of the sequence, so first term. And then the r is your common ratio. And then the n is the position of whatever term you have right here, or the term you're looking for, okay? So it's the position of, technically, whatever your a sub n term is, okay? So we're going to, I guess, continue this in the next lesson so that you could practice just finding the next 3 terms. And so in the next lesson, we will come back together and start writing these in the different forms.